Welcome to AI Patent Watch, the podcast where we break down an exciting AI patent in each episode, what it covers, why it matters, and how it's impacting innovation. Whether you're a patent professional, an AI enthusiast, or an inventor looking for inspiration, you're in the right place. Let's dive into today's AI patent.
Ever been there? You've got this great photo, almost perfect, but there's just something you want gone.
Oh yeah, that thing in the background. Or maybe, well, someone you cropped out mentally years ago.
Totally. And you reach for those like magic eraser tools on your phone or computer.
Sure. You tap it.
Uh-huh.
Sometimes it works okay.
Sometimes. But often you just get this weird blurry patch, right? Or like a strange repeating pattern. It looks fixed. Definitely not natural.
Exactly. It screams edited, doesn't it?
Yeah.
And forget about actually choosing what fills that space.
Right. That's the real frustration. You can erase, maybe, but you can't really replace it with something specific you want.
And that, really highlights the limitations of the older ways of doing this image fixing, this inpainting.
It's like trying to patch a hole in a painting with, I don't know, paint that's just close but not quite right.
Good analogy. It just doesn't blend seamlessly.
But what if there was a smarter way? Today, we're doing a deep dive into European patent specification EP4248397B1. This patent talks about machine learning models for something called example-guided image inpainting. Sounds fancy, but the idea is pretty cool.
Example-guided. So you give it an example.
Exactly. It's not just patching the hole based on what's around it. It intelligently blends in new stuff. And the key is it uses another picture, an example image you pick, to guide what goes in there.
I see. So instead of just guessing from the surrounding pixels, which, like you said, really struggles if the hole is big.
Yeah, definitely.
It looks at a whole different picture for, like, inspiration and maybe the actual content.
That's the core idea. It gives you way more creative control than just hitting fill.
That sounds like a real step up.
That's what we think, too.
Yeah.
So our mission today is to unpack why the old ways struggled, how this patent offers a really clever solution, and get into the nitty-gritty of how this tech actually works.
Okay. So folks listening should get a good handle on the main concepts and why this is kind of exciting.
Exactly. We want you to see the potential here.
All right. So let's maybe set the scene first. Before this example-guided stuff, what was the standard approach? You mentioned inpainting.
Right. Traditional image inpainting, it was all about fixing those missing or unwanted bits using only the information that was already in the damaged picture.
Like trying to fix a jigsaw puzzle piece using only the frayed edges of the piece itself.
Perfect. Works for a tiny tear, maybe. But what if a whole chunk of the puzzle is missing?
Then you're stuck. Right. You just don't have enough information in those surrounding pieces to figure out what the missing picture should be.
And that's the problem with big missing regions in photos using those older methods. The software has to guess a lot.
And the guesses aren't always great, which leads to
those blurry blobs we talked about?
Yep, lack of detail. Or, as the patent actually points out, you get these weird repetitive artifacts. They call them tessellations.
Oh, I know what you mean, like trying to fill a sky and it just stamps the same little cloud bit over and over.
Exactly that. It looks totally fake. Instantly breaks the illusion.
Yeah, it's a dead giveaway.
Absolutely.
Mm-hmm.
And another huge issue was just the lack of control. You couldn't tell the software, hey, for this missing bit, I want it to look like, this.
No creative input. It just did its thing based on the surroundings.
Right. So your example earlier, a modern building cut off, and you want to fill the gap with, say, a Gothic style.
Yeah.
Traditional methods. They just couldn't do that convincingly. Not really.
They'd probably try to extend the modern building lines or something.
Probably. Or make a weird mush.
Yeah.
It also had trouble figuring out which parts of the existing image to prioritize. The color, the texture, the shapes. Sometimes it latched onto the wrong thing.
Making the best guess with limited clues, like you said.
Exactly.
Yeah.
And trying to pull in something totally new, like visual elements from a different photo. Forget it. That wasn't really on the table.
So that's the wall they hit. You couldn't easily introduce new styles or content from another source.
Precisely. And that's the core problem. This patent, with its example-guided inpainting, is designed to crack. It's about adding that control and realism.
Okay, so let's get into this example-guided approach. How does using that separate guide image actually work?
Well, the fundamental idea is that the system doesn't just look at the image with the hole anymore. It also looks closely at this separate picture, the guide image you provide.
Okay.
And it uses the visual characteristics of that guide image to inform how it fills in the missing area. So right away, you get that control we were missing. Want a brick texture. Provide a guide image with bricks. Want a different color scheme? Use a guide image with those colors.
That sounds powerful, but how does it, merge the two? It can't just cut and paste from the guide, can it? That wouldn't look right either.
No, definitely not copy-paste. The clever part is how it blends the visual features from both the original image and the guide image.
Blends the features.
Yeah, it's trained to understand the underlying properties, the style, the texture, the shapes, and integrate them into the missing spot so it looks natural, like it belongs there. But it's taking cues from your guide.
So what kind of visual features can it actually grab from the guide image?
The patent mentions quite a few. Things like the overall color palette, the specific shades and tones.
Oh, okay.
Geometric features too, lines, shapes, structures.
Yeah.
Even frequency content. Think of that as like the level of detail or texture. Is it sharp or smooth?
Right, like fine detail versus blurry.
Exactly. And statistical properties, which is a bit more technical, but relates to how colors and textures are distributed. And maybe the most interesting one. Semantic content.
Semantic content. You mean like what the objects are in the guide image?
Yeah. It can understand, to some extent, the meaning of the pixels. Is it sky? Is it a building? Is it foliage? And use that understanding, inspired by the guide image, to fill the gap appropriately.
Wow. So it's looking deeper than just the surface appearance.
That's the goal. And this whole approach, using a guide image, gives you two massive advantages over the old way.
Okay. What are they?
First, as we've kind of been saying, control. You, the user, get a real say in how the filled-in part looks by choosing that guide image. You're not just rolling the dice.
Makes total sense. And the second advantage?
The second big one is it provides more information, especially for those really big holes in the original picture.
Where the surrounding pixels just aren't enough.
Exactly. The guide image brings fresh visual data to the process. It gives the system more to work with, allowing it to generate much more convincing results, particularly in those really trivial cases.
It's like giving it a reference library instead of just a few scraps of paper.
That's a great way to put it.
Okay, so we get the why. It's better. It's more controlled. Now, how does the actual invention described in this patent do it? What are the building blocks?
Right, let's look under the hood. The patent describes a system with a few key components working together. First up, you've got two encoders.
Encoders, like encoding the information.
Sort of. One encoder, labeled 320 in the patent's figure 3, takes your input image, the one with a hole. The other encoder, 310, takes your guide image.
And what do these encoders do to the images?
They process them to create what's called a latent representation. Think of it as a highly compressed summary or a sort of abstract recipe that captures the essential style and features of each image, but isn't the image itself. It's in a feature space.
So like the core essence of the image boiled down.
Kind of, yeah. And the patent knows these could be the same type of encoder model or different ones.
Okay, two latent representations, one for the input, one for the guide. Then what?
These two representations go into a latent representation operator, component 314. Its job is to combine these two recipes into one unified representation.
How does it combine them? Just stick them together?
That's one way the patent mentions concatenation, literally just joining them end to end.
Simple enough.
But it also describes a more sophisticated method using cross-attention.
Cross-attention, that sounds more involved.
It is. Cross-attention is a mechanism that helps the system figure out the relationships between the features in the two images, like which parts of the guide image are most relevant to the areas around the hole in the input image.
Ah, so it's looking for connections, for similarities.
Exactly. It's trying to make smarter connections than just mashing them together. Now, this combined latent representation feeds into the real powerhouse, the StyleGAN model, labeled 330.
StyleGAN. Okay, I've heard of that. That's the thing that makes those incredibly realistic fake faces and stuff.
That's the one. StyleGAN is a type of generative adversarial network, or GAN, known for generating really high-quality images and having great control over style. The patent even mentions different versions, StyleGAN 1, 2, 3, each with improvements like better style handling, fewer weird artifacts.
So they're using this powerful image generator.
Yes, and it's specifically trained to take that combined latent representation, the mix of input and guide features, and actually generate the new pixels for the inpainted area.
So the StyleGAN is actually creating the new image content.
Precisely. And crucially, it does this in a deep latent space. It's manipulating those abstract features we talked about, not just pixels. This lets it blend the characteristics from both images much more naturally.
It's synthesizing something new that fits, using the guide as strong inspiration.
You got it. It's not just pasting.
Right.
Okay, so StyleGAN creates the fill content, What's the last step?
Putting it all together.
Right. That's the job of the output image generator, 334. It takes the inpainted content from StyleGAN and slots it perfectly back into the original input image. It knows where to put it because of the inpainting mask, 306.
The mask is just the outline of the whole, basically.
It can be. Like a black and white map, fill here, don't fill there. But the patent says it could also be grayscale.
Why grayscale?
That could allow for softer edges maybe, like feathering the blend between the original pixels and the new inpainted ones, or maybe weighting the guide's influence differently near the edges.
Ah, for a smoother transition. Makes sense. You don't want a hard line.
Exactly. So the output generator uses the mask to seamlessly integrate the StyleGAN's creation. And boom, there's your final image.
Okay, that gives us the overview. You mentioned the StyleGAN part is key, and the patent goes into more detail there.
It does. Figures 4A, 4B, and 4C show different potential architectures or ways the StyleGAN can be set up for this task.
Let's unpack those a bit. What's figure 4A about?
4A shows a kind of standard StyleGAN setup. There's a mapping network that turns some random noise into an intermediate latent code. This code gets combined with our latent representations from the input and guide images. Then the synthesis network, built from style blocks, generates the image progressively, getting finer and finer resolution.
Building it up in layers.
Right. And it uses that combined latent code to sort of kickstart or initialize the synthesis process.
Okay, basic StyleGAN structure adapted for this. What about 4B? You said that's important for the claims.
Yes. Figure 4B introduces something really central to this specific invention, a similarity calculator.
Similarity calculator.
Yeah.
Does exactly what it sounds like.
Pretty much. Component 440 in the diagram. Its job is to measure how similar the guide image is to the input image, or specifically, to the area around the hole in the input image.
How does it measure similarity?
Could be a few ways. Maybe calculating the distance, like cosine distance, between their latent representations. Or it could even be a learned model trained just to judge visual likeness. And importantly, it can use the inpainting mask to focus this comparison on the relevant border regions.
So it's checking how well does this guide image visually match the immediate surroundings of the whole.
You nailed it. And then this similarity score, this metric, 442, is used to adjust how the StyleGAN works. It modulates the features inside the style blocks using things like modulators, 432, 436, and multipliers, 444.
So if the guide is very similar in some way, it lets that aspect influence the inpainting more strongly.
Exactly. It encourages the system to lean into the similarities, to incorporate things from the guide that already kind of fit with the input image. This helps make the final result much more coherent and believable. The patent claims really focus on this architecture with the similarity calculation built in.
That's clever. It's actively trying to make a good visual match, not just blindly follow the guide.
Right. It's about harmony. Then, figure 4C shows another idea, using cross-attention inside the StyleGAN's synthesis network.
We talked about cross-attention for combining the initial latent codes. How is it used here?
Here, as the StyleGAN is building the image layer by layer, those intermediate layers can look at or attend to the guide image's features, again focusing on parts that are semantically similar. If it's generating a patch of grass, it might pay more attention to grassy features from the guide's representation.
So even more interaction between the guide and the generation process itself.
Precisely. It's another way to ensure relevance and coherence. Now, as you can probably tell, this is getting pretty complex, right?
Definitely. Lots of moving parts, sophisticated techniques like StyleGANs, attention mechanisms, similarity metrics.
Exactly. And understanding the nuances of how these different architectures work, what's claimed in this patent versus others, that's crucial for anyone working in this area, whether you're developing new tech or investing in companies doing this kind of AI work.
It's a rapidly evolving field.
Absolutely. Yeah. And navigating the intellectual property landscape requires real expertise. This is really where having a patent attorney who deeply understands both the law and the technology itself is invaluable. Someone, for instance, like Bastian Best, host of this deep dive, and a European patent attorney who actually specializes in AI and software patents. They can help make sense of these complex specifications and protect innovation.
That's a really important point. Knowing the tech isn't enough if you don't understand the IP side, and vice versa. Okay, so back to the system. It sounds really flexible if the guide image is the main driver. Can I get different results for the same photo?
Oh, absolutely. That's one of the beauties of it. Take the same input image with the same mask, but feed it different guide images. You'll get different inpainted results each time, reflecting the style or content of the chosen guide.
Huge creative potential there. You could try out loads of different looks.
Definitely. It opens up a lot of possibilities.
Okay, let's maybe try and summarize the key points we've covered in this deep dive.
Sure. So we started with the old way, traditional inpainting. Its main problems were handling large missing areas and giving users basically zero control over the content.
Right. It just guessed based on nearby pixels, often leading to blurry or repetitive results.
Then we introduced this patents approach, example-guided inpainting. It uses a separate guide image to provide both extra information and stylistic direction.
And the engine driving this is a StyleGAN, a powerful image generator, but it's not just pasting, it's working in a latent space to blend features.
Exactly, blending features from both the input and the guide. And the patent specifically highlights innovations like using a similarity calculator to ensure the blended result is coherent and visually relevant to the original image context.
Plus, using things like cross-attention to find those meaningful connections between the images.
Right. It's a much more intelligent and controllable way to reconstruct or even reimagine parts of an image.
It really does feel like a leap. So, thinking bigger picture, if we can control image generation this precisely using examples, what does that mean? For creative software or generating content automatically?
That's the big question, isn't it? The implications are pretty vast. For creative tools, imagine artists trying out complex style transfers or modifications almost instantly just by providing examples.
Yeah, incredibly fast prototyping.
Or think about restoring old, damaged photos. You could use guide images of similar, intact photos from the same era to fill in missing parts with historically appropriate details and style.
Wow, that would be amazing for archives and history.
And then there's pure content generation. Maybe creating variations on designs or even generating scenes based on a description in a style guide image. It blurs the line.
It even makes you think about, visual memory. Could we use this to alter or inpaint our recollections visually? A bit sci-fi, maybe?
Maybe a little. But it certainly opens up philosophical questions about image manipulation and authenticity when the tools become this powerful and seamless.
Definitely something to ponder. So for our listeners, maybe think about how you might use tech like this. What annoying thing in a photo would you fix? And what guide image would you use to fill it in?
Yeah, what styles would you experiment with? And if you're really curious, you can always look up the patent number we mentioned, EP4248397B1, or just read more about StyleGANs online. There's a lot out there.
Absolutely. Well, this has been a fascinating deep dive into example-guided image and painting. It really shows how machine learning is pushing the boundaries of what's possible in the creative sphere.
It's an exciting space. The ability to intelligently fix, change, and reimagine images using examples just opens up so many doors.
And that's a wrap for this episode of AI Patent Watch. If you found this helpful, please take a moment to leave a 5-star rating and subscribe so you don't miss future episodes. This podcast is curated by Bastian Best, a European patent attorney specializing in AI patents. To learn more about the exciting intersection of patents and AI, sign up for his mailing list for exclusive insights. Link in the show notes. And if you're already working on the next big AI innovation, now's the time to secure your own patent. Reach out to Bastian on LinkedIn or the podcast website to turn your ideas into assets. Thanks for listening, and stay tuned for the next episode of AI Patent Watch.